Nothing, and I mean nothing like this, has ever been found in Petra. And beneath us, a discovery.
So what'd you find? We think we have an entrance to something here.
And it's just got these big blocks in front of it?
Yeah, it's been sealed up.
Petra rises from the Jordanian desert like a miracle carved in stone. For centuries, we've celebrated it as a masterpiece of ancient engineering, a Nabatean city with cascading fountains, hidden pools, and monuments carved taller than a 10-story building, without scaffolding, without blueprints, without ever stepping back to see the work. But what if everything we know about Petra is wrong? What if Petra isn't the beginning of the story? What if it's the end? When a drone equipped with 100 times deep penetration radar scanned Petra's oldest structure, scientists froze. Beneath flawless symmetry, earthquake-proof geometry, and acoustics rivaling modern concert halls, the radar revealed something impossible. Unnatural voids, buried layers, precision patterns that shouldn't exist in solid rock. No inscriptions, no tools, no rubble. Just impossible design, hidden deeper than anyone had ever looked. When engineers first scanned Petra's treasury using high-resolution photogrammetry in 2023, they expected to confirm what textbooks had been repeating for decades: that the Nabateans carved a beautiful monument using basic subtraction techniques. Instead, the scans returned measurements that made several researchers assume the software was malfunctioning. The facade, stretching 25 meters across and rising 39 meters high, is symmetrical to within 20 millimeters, a degree of precision normally achieved with laser-guided modeling or industrial stone milling machines. But this was carved 2,000 years ago by artisans standing on cliff edges, cutting downward into sandstone with tools believed to be bronze. Dr. and Judith Mackenzie from Oxford wrote that the only way such harmony can exist is if the builders understood mathematical relationships, like the 3:2 ratio and the golden ratio, before carving even began, meaning they had a detailed plan for every centimeter they removed. But here's the paradox that grips every archaeologist who's visited the site. When you carve from the top down, you can't step back to check your work. There's no vantage point inside the narrow SIQ canyon that allows you to see the full facade. Modern architects rely on drones, three-dimensional imaging, and digital modeling to maintain proportional accuracy on tall structures. The Nabateans supposedly performed the same feat without even the ability to view the structure in its entirety. One of the strangest discoveries came when tool marks were cataloged by Jordanian archaeologists. Every chisel strike appears almost identical in depth and angle, as if executed by a precision mechanism rather than human hands. Stonework experts note that fatigue alone should cause variation. After 1 hour of overhead carving, a modern carver's hand naturally shifts angle, pressure, and rhythm. Yet Petra shows no such human wobble. 8,500 cubic meters of sandstone were removed with a consistency that, according to Italian master stone carvers who examined the facade in person, should not be possible without modern machinery. There's a phenomenon inside Petra that archaeologists rarely discuss and tourists usually stumble upon by accident. It happens when you enter the chamber behind the treasury or stand at key points within the carved tombs. You speak and the sound doesn't echo. It doesn't bounce. It lingers, suspended, amplified, almost vibrating, before vanishing with unnatural clarity. Acoustic engineers who studied the Al-Khazni and the so-called monastery in 2019 found that the internal chambers have resonance profiles similar to those of purpose-built auditoriums. Except these chambers weren't built. They were subtracted, carved from solid stone. The implications are enormous because creating acoustics like this isn't accidental. It requires precise control over chamber volume, wall angle, surface texture, and material density. And these parameters must be calculated before any carving begins. In Roman amphitheaters, engineers use sloped seating, parabolic walls, and trial-and-error designs to perfect sound. But at Petra, the builders achieved that same auditory effect by removing matter, not adding it. Researchers from the University of Amman and MIT who analyzed sonic frequency responses in 2021 came to a chilling conclusion. Petra's builders intentionally tuned the stone using technology now lost. The best-known example is in the urn tomb, If you whisper near the rear wall, your voice is heard amplified and clearly across the entire front portico, a feature not even visible from outside. But how did they predict these effects without seeing the hole? Some theorists suggest they may have used vibrating plates or rudimentary resonance tests where sand scattered on vibrating surfaces reveals frequency patterns. But there's no evidence these methods existed in the region at the time. And even if they did, that wouldn't explain how the design was translated into subtractive rock carving without error. Long before you reach the grandeur of Petra's treasury, you pass something few notice: small stone channels carved into the cliffside running parallel to the Sick Canyon walls. At first glance, they look like natural grooves, but they're not. They're part of one of the most sophisticated water control systems in the ancient world, engineered to perfection. Petra receives less than 4 inches of rain per year and sits in an environment so arid it shouldn't support a thriving population, let alone a metropolis filled with gardens, fountains, pools, and ceremonial washings. Yet in its prime, Petra not only supported tens of thousands of residents, but exported water to outlying settlements. In 2015, hydrologists from King's College London published a groundbreaking report after mapping Petra's subterranean and cliffside water systems using ground-penetrating radar and infrared satellite scans. What they found shocked them. An extensive network of hidden cisterns, ceramic pipelines, pressure control chambers, and hydraulic regulators carved with such precision they could maintain constant flow rates over miles of uneven terrain. Even more remarkable, the channels were coated in waterproof plaster and included silt traps to prevent clogging, technology not expected in that region until at least 1,000 years later. One main aqueduct carved into vertical sandstone cliffs dropped only 30 meters over a 7-kilometer run, keeping water moving without stagnation or overflow. That level of gradient control requires modern surveying tools. The Nabateans had none, or so we thought. But here's where the mystery deepens. Some segments of Petra's aqueduct system cut through solid bedrock at angles and routes that suggest pre-existing knowledge of subsurface geology. There are no false tunnels, no test cuts. Every cut connects. It's as if the planners already knew where the faults, soft layers, and water-bearing seams were located without seismic tools. Petra sits in one of the most seismically active regions of the Middle East. The Dead Sea Transform Fault runs less than 60 kilometers away, and historical records confirm at least 5 major earthquakes struck the region between the 1st and 8th centuries. In theory, Petra's monuments should be rubble. Vertical facades carved from brittle sandstone are especially vulnerable to seismic shear. Yet the treasury, the monastery, and dozens of towering tombs remained standing while later built Roman additions collapsed. In 2014, a joint seismic study by Jordan's Department of Antiquities and researchers from ETH Zurich examined fracture propagation across Petra's monuments. What they found was unexpected. Stress cracks stop abruptly at specific carved transitions. Rather than continuing through the structure as physics predicts, these stress breaks act like shock absorbers, dissipating seismic energy instead of amplifying it. Modern earthquake-resistant buildings use expansion joints, flexible layers, and engineered weak points to prevent catastrophic failure. Petra appears to have these features, but carved directly into solid rock. Certain columns aren't fully attached to the cliff face. Some corners float millimeters away from the rear wall. These aren't errors. They're intentional separations that allow micro-movement during ground motion. Ground-penetrating radar scans reveal that several major facades are backed by relief chambers, empty spaces carved behind the visible surface. These voids reduce mass and lower the structure's seismic load, similar to hollow core construction used in modern skyscrapers. There's no decorative reason for these chambers. They serve no burial function. Their only clear benefit is structural resilience. What complicates matters is that later Nabatean and Roman structures at Petra don't use these same features, and they failed. Columns toppled, walls cracked, roofs collapsed. The advanced seismic logic appears selectively applied, concentrated in the most precise monuments. The oldest, most sophisticated structures survive forces that destroy newer ones. Technology regresses instead of advancing. With all this advanced engineering, where did 8,500 cubic meters of rock disappear to? Just the treasury alone required the removal of roughly 8,500 cubic meters of solid sandstone. To put that in perspective, that's enough rock to fill 3 Olympic-sized swimming pools. Yet today, there's no massive spoil heap, no scattered rubble, no quarry dump nearby that matches the stone removed from the treasury. In ancient quarries around the world, from Egypt to Greece, huge piles of discarded stone still lie where workers left them. Petra, however, is different. Its landscape is almost unnervingly clean. In 2020, a team led by geologist Dr. Lorenzo Zambelli of the University of Bologna tried to track down the missing stone. Using sediment analysis and aerial LiDAR mapping, they found several mounds east of the city, but none contained sandstone that matched the treasury's distinctive grain and color. Was the stone deliberately removed and taken far from Petra? And if so, why? And now, what the drone's 100 times deep penetration radar actually found beneath Petra's treasury. The scan revealed unnatural voids carved with geometric precision, buried layers that form interconnected chambers beneath the monument, patterns in the bedrock that suggest intentional design rather than natural formation. These hidden structures align perfectly with the surface features, the acoustic chambers, the earthquake-resistant separations. Whatever technology created Petra's impossible precision, it didn't stop at the surface. It went deep into the rock, creating a three-dimensional architecture that connects everything into one unified, unexplained system. Petra has always been a mystery wrapped in stone, but the drone's radar scan has revealed something far stranger than anyone imagined. What we thought was the achievement of a nomadic merchant culture now appears to be something else entirely. Perhaps the remnant of a lost civilization. Perhaps inherited knowledge from a time before recorded history. The impossible precision, the acoustic engineering, the earthquake resistance, the vanishing stone. Every mystery wasn't a separate puzzle. They were all clues pointing to what lies beneath. The treasury of Petra may not be a treasury at all. It may be a gateway, a marker, a key to an underground world that's been sealed for thousands of years. And now, for the first time in human history, we know it's there. The question is no longer how did they build Petra? The question is, what were they building it for? And perhaps more importantly, what's still down there waiting to be found? If this discovery has left you stunned, hit that like button and subscribe. Because when they finally open that sealed chamber 35 meters below the treasury, you'll want to be among the first to know what they find.